This is a walk-in type stability chamber. This is an air processing unit at the back side of the chamber consisting of blower, air heater, cooling coil and humidity system. The air is drawn inside the air processing unit, conditioned and pushed back into the chamber. This is the refrigeration system. We keep the refrigeration system outside the chamber in a well-ventilated service area. It consists of two compressors, regular and standby compressor. There is copper piping connection to the cooling coil which is circulating the refrigeration gas. Whenever there is a refrigerant gas circulating inside the cooling coil, the temperature of the cooling coil is at 7 degrees Celsius. The chamber conditions maintained are at 25 degrees Celsius 60% RH, 30 degrees Celsius 65% RH and 40 degrees Celsius 75% RH. The cooling coil temperature is 7 degrees Celsius for all the conditions. To achieve 25 degrees Celsius, 30 degrees Celsius and 40 degrees Celsius, when the cooling coil temperature is at 7 degrees Celsius, we have to reheat the air with air heaters of 5 kW, 6 kW and 7 kW capacity. We do extensive cooling and then by means of reheating, we maintain the required temperature inside the chamber. When there is extensive cooling, there is extensive dehumidification going on. For example, if this air-conditioned room is set at 25 degrees, the humidity in this room will be around 60% RH. If you set the temperature at 22 degrees Celsius, the humidity will further drop down to 55% RH. In our unit, we are doing extensive cooling, resulting in extensive dehumidification. To counter that, we need to put on more humidity in the chamber. The humidity heaters required are 3, 4 and 5 kW each. In this system, we are overcooling and over-dehumidifying with the compressor running for 24 hours and 365 days. In this condition, we are reheating and humidifying all the time. This is how the temperature is controlled in the chamber. The compressor is on 100% of the time and you cannot switch on and off the compressor. This was the old method used by Thermolab. This is the walk-in type stability chamber. This is an air processing unit at the back side of the chamber consisting of a blower, an air heater, a cooling coil and a humidity system. Same as earlier, the air is drawn inside the air processing unit, conditioned and pushed back into the chamber. We control the temperature of the chamber with the help of chilled water refrigeration system known as hydronic system. This is an insulated refrigeration system. This is a regular compressor and this is the standby compressor. The cooling coil of both regular and standby compressor is inside the insulated tank consisting of a hydronic liquid with the temperature controller attached to it. This is an independent unit manufactured in the factory. We can control the hydronic liquid temperature based on the chamber temperature. Again, taking the ICH conditions, 25 degrees Celsius 60% RH, 30 degrees Celsius 65% RH and 40 degrees Celsius at 75% RH. For 25 degrees Celsius, we have to set the hydronic liquid temperature at 14 degrees Celsius. For 30 degrees Celsius, we have to set the hydronic liquid temperature at 23 degrees Celsius. And for 40 degrees Celsius, we have to set the hydronic liquid at 30 degrees Celsius. The cooling coil temperature is now variable 14 degrees Celsius, 23 degrees Celsius and 30 degrees Celsius. Now we have to take the temperature from 14 degrees Celsius to 25 degrees Celsius, 23 degrees to 30 degrees Celsius and 30 degrees to 40 degrees Celsius, and not from 7 degrees to 25 degrees Celsius, 7 degrees to 30 degrees Celsius and 7 degrees to 40 degrees Celsius. So we require less reheating power and consequently can use lower capacity air heaters. For example, if you set the chamber temperature at 30 degrees Celsius, the hydronic liquid temperature at 23 degrees Celsius, the condensing unit will cool down the hydronic liquid, and when it is 23 degrees Celsius, it will switch off. If the hydronic liquid temperature rises to 24 degrees Celsius, it will switch on. The switch on time will be 10 to 15 minutes and the switch off time is 30 to 40 minutes approximately. The pump will circulate the hydronic liquid inside the cooling coil. As the temperature difference is not much, the air heater required are 2 kilowatts, 1 kilowatt and 1 kilowatt. Since our cooling coil temperature is not 7 degrees Celsius and instead 14 degrees, 23 degrees and 30 degrees Celsius, there isn't much dehumidification and there is no need to inject more humidity inside the chamber. Hence, the humidity heater capacity are reduced to 1 kilowatt, 1 kilowatt, and 1.5 kilowatt. If you compare the earlier air heater and humidity heater power rating in kilowatts with current required kilowatts, there is more than 60% reduction in the electrical consumption. The second advantage is the wear and tear of the compressor. In the earlier system, the compressor was running 100% of the time, and in the new hydronic system, the compressor is running only 10 to 20% of the time. Hence, the wear and tear of the compressor has reduced and the life of the compressor has increased. These advantages were in terms of the engineering point of view. But from an application point of view, the main advantage is the recovery of the condition when the power fails. For example, when the power fails, all the components shut down. The power is restored by the means of a generator within a couple of minutes. All the components will start except the compressors, because compressors have a time delay protection of 3 to 4 minutes. In these 3 to 4 minutes, the relative humidity and temperature in the chamber will fluctuate and you may get a deviation. In our new hydronic system, if the power fails and is restored, all the components will start except the compressor. The pump will start immediately because it does not require the time delay. When the blower and the pump start, the temperature controlled liquid inside the insulated tank will start circulation and the air temperature will be maintained inside the chamber. This is the main advantage of the user. The advantage of using the hydronic system is that it reduces the electrical consumption by 60% and the water consumption by 90%. The wear and tear of the compressor has reduced along with the fast recovery conditions. We have applied for the patent for this technology.